In this video, we're gonna talk about how to simplify surds. So of course, we talk about some surds that can't be simplified. So like square root of 7. But we can simplify some like square root of 27. Why is this? It's because 7 has like no factors that we can like square root. So like nothing really times to it. But for 27, you can times 9 by 3. That'll give you 27, right? But how do we simplify this? So firstly, we would, okay, when we times surds, it's basically the same as putting them together. So it's surd 9 plus surd 3 equals square root of 27, right? Because you're just timesing these two. And then, so we can see that there's multiple ways that we could get to this. Okay, one way is this 27 times 1, and that will give us square root of 27. But this is not useful. Why? Because we can't use it to simplify it to a square number. So, for example, 9, the square of 9 is the same as 3, because, yeah, and you can't square root 3 any further, so it would just be, okay, look, there's a times here, so it's basically the same as putting it together. So it would be the square root of, it would be 3 square root 3, and that's how you just simplify this. But what if it was something like square root of 100? Well, we'd use the same rule, so we would have to find something that would square root to this. Find a factor, so like 10 times 10, or 25 times 4, or 50 times 2. Okay. So for this, we're basically looking for like something that can be square rooted. And 10, it can't be square rooted anymore. So not that. But 25 can be square rooted to a just 5. And 50 can't be just by itself. So using this knowledge, we can turn it as 5 square root of 4, which we then can simplify even further. So using the same rule as we did up here, we can find factors that give to that, to give to another square root. So 2 times 2 equals 4, and this and we can just it would actually just equals 5 times 2 equals to 10. You could actually just put this in your calculator. This is another way of figuring it out. Then we have something like the square root of, let's say, right? We have to figure out ways that we can solve it. So it would be like 12 times 4 or 6 times 8 or 48 times 1. So using our previous knowledge, we have to find a square root, and I forgot to mention this before, but our square roots say 2 squared equals 4, 3 squared equals 9. You get it? Like, it just keeps going. So our first one, we can already see that there's a square root of 4. So we can use that to put it on the outside. So basically, it would be 2, 12. But we can square root this even further, because there's the factors are 3 and 4, and 4 is also a square root. I mean, square is a number. So we can do that again. First, we need to get our number on the outside, 2. Then we get this times 2, and we get this value times 3. So our final value would be 2 times 2, which equals 4, and the square root of 3. Okay, but how would we do that how would we reverse it? I mean, so we would really just, okay, so we're trying to get back to a original number, right? And we have something like this. Oh, that's bad example. 3, 6. Okay. And we know from before that this used to be a square root, but it was something bigger, right? And it was just it times together. So it would be square of 9, because when you square root 9, it equals 3. It's like vice versa. Okay, but what do we do with that information? Well, before, we know that this square root of something, square root of x, is equal to square root of b plus times something else. So basically what I'm saying is you can times this value by this value to get to your original surd. So square root of 9 times square root of 6 is equal to 54. Square root of 54. Yeah,